अब चेक करो जी ऑडियो। अब चेक करो जी ऑडियो, चेक करो अब चेक करो जी ऑडियो, अब चेक करो। इज इट क्लियर नाउ? Okay, okay. Right, the first point. Right, first point. Identify total number of meshes. Identify total number of meshes in the given network. First point. Identify total number of meshes in the given network. Total number of meshes in the given network. Second point. Second one. Assign the current direction. Second point. Assign the current direction for each mesh. Assign the current direction for each mesh. Next point. Develop KVL equation. Develop KVL equation. Develop KVL equation for each mesh. Develop KVL equation for each mesh. Next point. By solving KVL equations, find loop currents. By solving KVL equations, find loop currents. By solving KVL equations, find loop currents. Find loop currents. अब चेक करो जी, इधर इक्वेशन 2, कैन यू सब्स्टिट्यूट इक्वेशन 2 इन इक्वेशन 1? Substitute equation 2 in equation 1. Check करो जी. Do the substitution simplified, find out the I1 value. Substitute the equation 2. Substitute the equation 2 in equation 1. Check करो. Do the substitution, find out I1 value. Okay, I understand. Some students are asking doubt about the equation 1. I understand. देखो इधर सुनो एक बार. Lower potential to higher potential voltage rise. In the 2 ohm resistance, what the current circulating is the I1. 2I1. 3 ohm resistance में I1 downwards, I2 is the upwards. The 3 ohm resistance में I1 downwards, I2 upwards, opposite direction. कैसे लिख सकते हैं? 3 of I1 minus I2. 3 of I1 minus I2. एक बार चेक करो जी. Separate the I1 I2 quotients. Separate I1 I2 quotients. You get this equation only. You get this equation only. It is the easy way of writing equation. ये सब कुछ लिखने की जरूरत नहीं है. आप फौरन बोलते चेक कर लो. सिंप्लीफाई करते यही आते इक्वेशन. कैसे लिखते हैं इधर? I1 सर्कुलेटिंग द 2 and 3, 2 and 3 दोनों में जा रहे हैं, 2 + 3, 2 + 3 is 5. 3 ohms के लिए कैसा हो रहा है इधर, I1 डाउनवर्ड्स, I2 अपवर्ड्स, अपोजिट डायरेक्शन बोलते हैं नेगेटिव. ओके, I hope your doubts are cleared. Somebody asked doubts. Now कितना is I1 equal to check करो. Many students are saying 0.8. Is it correct? Okay, very good. Now observe here. Now correspond to mesh analysis. Total number of equations equal to total number of meshes. Correspond to this mesh analysis, total number of equations equal to total number of meshes. देखिए, in this example how many meshes are there? 2 meshes. Total number of equations equal to total number of meshes. Write this one. Total number of equations equal to total number of meshes. Total number of equations equal to total number of meshes. अमित सिंह, क्या है जी प्रॉब्लम, क्या है जी अमित सिंह जी? In this example, to find out the equations, we can use one more formula also. B minus of n minus 1. You can use one more formula also. B minus of n minus 1. In this example, meaning of B number of independent paths. B is the branches. Independent paths. Independent paths. Do you remember this one? In the previous classes, when we discussed about KCL, we concluded. In the branches also, 2 types of branches are there. One is a simple branch, other one is an independent path. One is simple branch, other one is an independent path. Now for this example, meaning of n is total number of principal nodes. Meaning of n is total number of principal nodes. Now for this example, independent paths. देखो जी कितना है independent paths? देखिए independent path 1, 2, other one is a 3. That means for this particular example, how many independent paths are there? 3. Number of independent paths are 3. Meaning of n nothing but a total number of principal nodes. देखो जी, this is a principal node 1. What about this one? Principal node 2. Principal node 1, principal node 2. Total how many principal nodes are there? 2. 2 minus 1. If you simplify this one, then how many equations? 2 equations. आप ये simplify करें तो total how many equations? 2 equations. Now this second formula is important. Objective questions के लिए second formula is important. Okay. Kushi Sharma, in the further steps I'll take some more examples, don't worry. I'll take some more examples, we'll get some clarity in the mesh analysis. Okay, and one more thing. In this particular example, how many equations are required here? 2 equations. But the questions, they may give statement like this. To find out the loop currents in this one, minimum how many equations are required? In the questions, they may give one sentence as a, to find the loop currents in this one, minimum how many equations are required? देखिए चेक करेंगे. every time remember as a, whenever he is asking the minimum number of equations, concentrate on the actual KVL equations. If he is focusing minimum number of equations, concentrate on the actual KVL equations. इधर देखो जी, लूप 1 के लिए we developed one KVL equation. लूप 1 के लिए we developed KVL equation. देखिए लूप 2, for loop 2 have developed any KVL equation? No. Current source is there, directly got answer. The current source है, directly got answer. That means how many actual KVL equations are developed? For this particular example, only one KVL equation is developed. But loop 2 current source is there, directly got answer. That means how many actual KVL equations are required? Only one equation. How many actual KVL equations are required? Only one equation. That means minimum how many equations required? Only one equation. That's why in the given example, whenever they ask the minimum number of equations, पहले क्या करो? Current source को check करो. जिधर current source है, no need to write any equation. Directly you can say the answer. For remaining loops only, we can write the KVL equation. Write one note. Write a note. In the above network, to find the loop currents, in the above network, to find the loop currents, in the above network, to find the loop currents, minimum one equation is required. Minimum one equation is required. Minimum one equation is required. Underline that word minimum. Underline that word minimum. In the brackets write KVL equations. In the brackets write KVL equations. In the brackets write KVL equations. KVL equations. That is one. Find at the next one. Find loop currents of the network shown. Find loop currents of the network shown. Find loop currents of the network shown. Okay. Now let's check it out. Now for this example, come to the loop 1. Come to the loop 1. For this loop 1 here, lower potential to higher potential voltage rise. 24. This I1 current circulates. I1 current circulates the 10 and the 12. I1 current circuit 10 and 12. What is the total resistance? How much? 22. 22 I1. For the 10 ohm resistance के लिए I1 downwards. What is the I2 is the upwards. The 10 ohms के resistance के लिए I1 downwards, I2 is upwards, opposite direction. कैसे लिखते हैं इधर? -10 I2. And for this 12 ohm resistance, I1 downwards. What is the I3 is the upwards. I3 is upwards, opposite direction. -12 I3. We got the equation 1. Equation 1. Can you try for loop 2 also? आप ट्राई करो, सोचिए एक बार loop 2. Loop 2 आप ट्राई करिए. Just think, I'll explain. Yes, Akash. Where it is independent source or dependent source. Path means only one current has to be circulated. इंडिपेंडेंट पाथ बोले तो पूरा पाथ में एक ही करंट सर्कुलेट होना है. I2 current circulates 24, 4 and the 10. For this example, I2 current circulates 24, 4 and 10. What is the total resistance equal to how much? 38. Now for this 4 ohm resistor, I2, I3 both are in the opposite direction. Minus 4, I3. Now in the 10 ohm resistance, I2 and I1 both are in the opposite direction. Minus 10 I1. Now this entire equation equated to 0. Entire equation equated to 0. Can you write the loop 3 also? Now correspond loop 3, I3 current circulates in the 12 and the 4. In this example, I3 current circulates 12 and 4, 16 I3. In the 4 ohm resistance, I3, I2 both are in the opposite direction. Minus 4 I2. Now for this 12 ohm resistance, I3 and I1 opposite direction. Now here the higher potential, lower potential voltage drop. If you write the voltage drop this side, what is the sign for this one? Minus. What is the sign for this one is a minus. Now we got the three equations. But if you have the three equations, how many unknowns are there? The answer देखिए. How many unknowns are there? I1, I2, I3. और एक unknown क्या है इधर? What is the one more unknown is I0. समझ रहे ना? I am writing the 4 I0 this side. अब this side लिखे तो क्या लिख सकते हैं इधर? Minus. देखिए I0 is the current of this branch. I1 downwards, I2 is upwards. इस एग्जाम कैसे लिखते हैं इधर? I1 is downwards, I2 is upwards. I0 is downwards. कैसे लिख सकते हैं रिलेशन? दिस I0 equal to I1 minus I2. I0 equal to I1 minus I2. अब सॉल्व कर सकते हैं ना? Dear students, here to understand the concepts, I have taken the example as a conventional question. By looking this one, don't lose the confidence. It is actually a conventional question. To get the clarity about the KVL equations, I have taken a lengthy question. अब सॉल्व कर सकते हैं ना? And one more thing, dear students, in the conventional questions, calculator operation plays a very, very major role. Conventional question में difficulty क्या है बोले तो even though you know the answer for all the questions, you cannot find the time for presentation. That's why especially in the mains conventional questions point of view, be thorough with the operational calculator. In our subject here, with respect to conventional questions, mainly three things you have to learn. One is how to enter equations in the calculator. जो equations है ना, सब equations directly calculator में enter कर सकते हैं. From that one directly you can find out the unknown values. Second method क्या है बोल तो conversion, rectangle to polar form, polar to rectangular form. आपको कुछ भी नहीं पता है तो rectangular, polar names, don't worry. In the second chapter again we discuss very clearly. Third one is the addition, rectangular addition, polar addition. Try to be thorough with all these things. Suppose you don't know about all these things, simply enter your calculator number in the Google. All the video manuals are available. Only you have to spend the 5 minutes time to learn all these things. Okay, remember as a calculator operation plays a very, very major role in the conventional questions. Check करो जी. somebody asking how 38 I2. देखो जी I2 कैसे सर्कुलेट हो रहा है, I2 सर्कुलेट इन द 24 4 एंड 10, 24 4 एंड 10 सब मिलाएं तो कितना होता है, 38 ही होता है. भावना, आई एम सेइंग कैलकुलेटर कन्वेंशनल क्वेश्चंस के लिए जी, ईएससी मेंस के लिए बात कर रहा हूँ. गेट में ओनली वर्चुअल कैलकुलेटर इज अलाउड. आई एम सेइंग विथ रेस्पेक्ट टू मेंस. देखिए यू अपडेट दैट वन फॉर गेट, गेट का अलग है, गेट में वर्चुअल कैलकुलेटर रहते हैं. ओ दुबे, गूगल में आपका कैलकुलेटर नंबर एंटर करो जी, एंटर करो तो सब कुछ आ जाते हैं आपको. ओके, लूप एंड मेश डेफिनेशन चाहिए. ओके, डोंट वरी, आई विल डिक्टेट दैट वन आल्सो, डोंट वरी. अब पहले गिव द आंसर्स, गिव द आंसर फॉर I1 I2 I3, then I will give the dictate that one also. Many students are saying answers. Many students give the answers. चेक करो जी एक बार. 2.25 और क्या है, कितना है जी? somebody is saying 0.75, 1.5. एक बार चेक करो जी आंसर्स. Okay, very good. Many students got same answers. Oh. At the beginning you have taken these figures now. They write some points. At the beginning you have taken these figures now. Write some points. Mesh is a loop. Mesh is a loop. Mesh is a loop. It does not consist of. Mesh is a loop. It does not consist of any inner loop. Mesh is a loop. It does not consist of any inner loop. It does not consist of any inner loop. Mesh is a loop. It does not consist of any inner loop. Next point. When the network is drawn on plane, when network is drawn on plane without any the network is drawn on plane without any crossover. The network is drawn on plane without any crossover. I have written here. When the network is drawn on plane without any crossover, then it is known as planar network. Then it is known as planar network. Planar network. Next point. Mesh analysis is valid. Mesh analysis is valid only for planar networks. Mesh analysis is valid only for planar networks. Mesh analysis is valid only for planar networks. Okay. Okay, previously somebody requested this one. Jindal, a 100 p is a loop. Jindal is saying this is a 100 p is this is a loop, LOP loop. बड़े मियाँ क्या बोल रहे हैं, ज़्यादा हो गया कॉन्सेप्ट्स आपको. It is a loop, it is not 100p, you are saying 100p. 100p क्या है जी? It is starting we identify number of loops ना. Okay? Write the next one. Write next question. Find I naught. Find I naught of the network shown. Find I naught of the network shown. Draw this figure. Meaning of loop is it may or may not consist of inner loop. आप लिख लो त्रिपाठी जी, I give hints. Now corresponds example. Due to voltage source, if any current is coming here, it cannot go to loop 2. Reason is here the no return path is exist. Reason is no return path is exist. Due to this voltage source, if any current is coming here, it cannot go to loop 1. Reason is no return path is exist. That means loop 1 and loop 2 both will operate independently. Can you find out the respective current of this one? I1 equal to, what is the voltage, how much? 100. 2 into 8. What is the I1 equal to how much? 10 amperes. I1 equal to 10 amperes. Here the wherever the current is entering, there is a positive, other one is a negative. For this one, I1 10 amperes, resistance is 8. What the voltage will be? 80 volts. I1 into 8, 80 volts. Now let us find out the respect to I0 value. Let us find respect to I0 value. For this example, what is the voltage? How much here? 4 VAB. 4 VAB. What about this one? How this 1 and 3 both are connected in series. That means here I0 equal to VAB. This I0 equal to VAB. Voltage of 4 VAB, 3 and 1 both are in series. In this example, wherever the current is entering, there is a positive, other one is a negative. Voltage is 3 ohms, let us name as a V dash. Voltage is 3 ohms, let us name as a V dash. In this example, V dash equal to, your current कितना जा रहा है जी? I0 current, resistance is 3. Current कितना जा रहा है? I0 current, resistance is 3. What is the V dash equal to 3 I0? What is the V dash? V dash equal to what is 3 I0? Can you substitute this equation 1 and 2? अब और एक KVL equation लिखेंगे. For this example, can you write the KVL equation? Can you write the respective KVL equation? If you write the KVL equation for this one, देखिए इधर. For this example, lower potential to higher potential voltage rise, and the higher potential to lower potential voltage drop. Again here also higher potential to lower potential voltage drop. This entire equation equal to 0. देखिए आपको दिस रिलेशन पता है. इक्वेशन 1 क्या है जी? VAB इज इक्वल टू I0. VAB इक्वल टू I0. VAB इक्वल टू I0. इधर V dash. V dash इक्वल क्या लिख सकते थे? 3 I0. For this example, V dash is a voltage का 3 ohm resistor. What will reduce 3 I0. अब इधर सिंप्लीफाई करके I0 निकाल सकते हैं ना? सिंप्लीफाई करो, सिंप्लीफाई करने से यू कैन फाइंड आउट द I0. सिंप्लीफाई करो जी. चेक करो. I0 इक्वल 20 एम्पियर्स. Okay, right. Next one, find equivalent capacitance. Find equivalent capacitance with respect to A and B. Find equivalent capacitance with respect to A and B. पूनम त्रिपाठी, वीडियो अपलोड होने के बाद और एक बार देख लो जी, लूप क्या है, मेश क्या है. ओके, in this example, what is the requirement? Equivalent capacitance with respect to A and the B. Here assume any source. Assume any source. इधर देखिए त्रिपाठी, पूनम त्रिपाठी. See, it is a mesh 1, it is a mesh 2. Every mesh can be called as a loop. Loop 1, loop 2. देखिए इधर, this entire outer one we can call as a loop, we cannot call as a mesh. क्यों बोलते हो? Whenever you are going for this outer one, again the two inner loops are present. That's why for this particular example, how many loops are there? 3 loops. Because outer one also one loop. But how many meshes are there? 2 meshes. Mesh 1 and the mesh 2. In the mesh, no inner loop should be present. देखिए, in this one no inner loop is there. But if you go for outside 2 inner loops are there. Okay. Now, in this example, with respect to A and B, assume the voltage source Vs. Now loop current of this one, I1, in the question itself given I1 current, and current of this one is a 49 I1. 49 I1. Can you write the respect to KVL equation for this one? Can you write the respect to KVL equation? Here by KVL equation, what is source voltage? How much? Vs. Source voltage how much? Vs. In this I1 3 ohm resistor, what a current circulating is the 3 I1. In 3 ohm resistance, what a current circulating is the I1. Now in this capacitor, I1 downwards, 49 I1 also downwards. In this one here, I1 downwards, 49 I1 also downwards. Both are in the same direction. What is the formula? 1 by C integral of, can I write this here? Now for this example here, I1 downwards, 49 I1 also downwards. Both are in the same direction. Same direction बोलते क्या है जी? Addition. Same direction बोलते addition. In the same figure, 3 I1. If you rearrange this equation, shall I say 50 by 100 integral of I1 dt. 50 by 100 integral of I1 dt. In the question, what they asked the equivalent capacitance with respect to A and B. देखो जी, with respect to A and B, करंट कितना है इधर? I1 करंट. With respect to A and B, सोर्स वोल्टेज कितना है इधर? Vs. आप A and B पॉइंट से देखें तो सोर्स वोल्टेज कितना है जी? Vs. करंट कितना है इधर? I1. नो क्वेश्चन में क्या पूछ रहे हैं आपको? इक्विवेलेंट कैपेसिटेंस विथ रेस्पेक्ट टू A and B. देखिए, कैन यू कंपेयर दिस इक्वेशन विद जनरल फॉर्म? कैन यू कंपेयर दिस वन द जनरल इक्वेशन वी एस इक्वल टू विथ रेस्पेक्ट टू ए एंड बी कितना है जी सोर्स वोल्टेज वी एस बट करंट कितना है इधर I1 द करस्पॉन्डिंग इक्वलेंट रेजिस्टेंस द आर इक्वलेंट क्यों बोलते हो ए एंड बी से देखे तो सोर्स वोल्टेज वी एस करंट कितना है जी I1 कोएफिशिएंट टेकन एज आर इक्वलेंट सिमिलरली इंटीग्रल ऑफ I1 कोएफिशिएंट इज टेकन एज ए 1 by C equivalent integral of I1 कोएफिशिएंट taken as a 1 by C equivalent. Suppose in the same question inductor is also there. If inductor is also there, then what do you write this way? L equivalent dA by dt. L equivalent dA by dt. Now for this example क्या चाहिए क्वेश्चन में क्या पूछे आपको equivalent capacitance with respect to A and the B. Now for that one can you compare these two equations? What is the integral of I1 coefficient indicate the 1 by C equivalent. What the integral of I1 is this 50 by 100. Then if you compare these two equations, in this example if you compare these two equations, shall I write this here 1 by C equivalent 1 by C equivalent equal to 50 by 100. If you compare these two equations, now from this one we can conclude this one as C equivalent, but C equivalent is equal to 2 farad. आप यार सिंप्लीफाई करने से C equivalent is a 2 farad. C equivalent is a 2 farad. अर्पित देव जिधर आपको इक्विवेलेंट वैल्यू चाहिए विथ रेस्पेक्ट दैट वन वी कैन एज्यूम वन सोर्स. ओके ध्रुव लूप टू का जरूरत नहीं है जी. लूप टू का करंट सोर्स दे दिया ना क्वेश्चन में. ध्रुव इधर लूप टू का जरूरत नहीं है क्वेश्चन में दे दिया. देखो करंट सोर्स दे दिया आपको. करंट सोर्स पता है आपको 49 I1. लूप टू के लिए केवल इक्वेशन जरूरत नहीं है. एंड वन मोर थिंग, a 200 farad does not influence the calculation. क्यों बोलते याद है आपको? when the element connected in series to current source element can be neglected. When the element connected in series to current source element can be neglected. Can you apply that logic here? In the first class I discussed it when we discussed about current sources. When any element connected in series to current source element can be neglected. That's why 200 farad does not influence the calculation. Okay. Shubham Sharma, I hope your doubt is clear now. I hope all of you remember this figure now. When resistance connected in series to current source, equivalent value is the only current source. I hope all of you remember this logic. The same logic we can apply here. When capacitor connected in series to current source, this capacitor can be neglected. Okay, 200 farad capacitor does not influence the calculations. Prince Kumar, इधर देखिए Prince, I1 downwards, 49 I1 also downwards. Both are same direction means what to write the plus. Both are same direction plus. Okay. Complete now? Yes. S. Vikas Kumar. Better. Next one. Find loop currents. Find loop currents of the network shown. Find loop currents of the network shown. Okay. Now observe. Now for this particular example, only correspond loop 1. Directly we cannot write the KVL equation. Reason क्या है बोलते हो? देखिए इधर लूप 1 के लिए वोल्टेज कितना है जी 20. इधर वोल्टेज कितना है इधर Vx. But we don't know what is the voltage current source. but we don't know what is the voltage across the current source. That's why only correspond loop 1, we cannot write the directly KVL equation, नहीं लिख सकते directly. Come to loop 2. Loop 2 इधर voltage कितना है जी 3 into I2, voltage कितना है इधर 5, but we don't know what is the voltage across the current source. We don't know what is the voltage across the current source. That means directly for loop 2 also we cannot write the KVL equation. For loop 2 also directly we cannot write the KVL equation. Reason क्या है बोल तो we don't know what is the voltage across the current source. We don't know what is the voltage across the current source. Then here, when the current source branch is common for two meshes, when the current source branch common for the two meshes, it is possible to find solution. It is possible to find solution by using super mesh technique. It is possible to find solution by using super mesh technique. With respect to super mesh technique, equation combinedly developed for mesh 1, mesh 2, excluding current source. With respect to super mesh, equation combinedly developed for mesh 1, mesh 2, excluding current source. Write one note. एक note लिखो इधर. एक note लिखो इधर. When the current source branch when the current source branch is common for two meshes, when the current source branch is common for two meshes, when the current source branch is common for two meshes, it is possible when current source branch is common for two meshes, it is possible to find solution. It is possible to find solution by using super mesh technique. It is possible to find solution by using super mesh technique. Now observe here. Now in this example, with respect to this super mesh, in this example here, with respect to this super mesh, equations combinedly developed for mesh 1, mesh 2, excluding current source. Equations combinedly developed for mesh 1, mesh 2, excluding current source. Let us write the combined equation. Let us write the combined equation. Now for this example here, 20 volts, lower potential to higher potential, voltage rise. In the 2 ohm resistance, what current circulating is the I1, 2 I1. In the 3 ohm resistance, what current circulating is the I2, 3 I2. What about this one, higher potential to lower potential, voltage drop? This entire equation equal to 0. This entire equation equal to 0. We developed the combined equation for loop 1 and loop 2, excluding current source. Combined equation excluding current source. What we applied for this one? KVL. What we applied here? KVL. Now let us focus on current source. अब current source के ऊपर focus करेंगे. देखिए current source के लिए I1 downwards, but the I2 is the upwards. For this example here, I1 downwards, I2 is upwards, opposite direction. Opposite direction कैसे लिख सकते हैं इधर? I2 minus I1. कैसे लिखते हैं इधर? I2 minus I1. What is the I2 minus I1 equal to Vx by 2. Now we got a current relation. इधर current relation बोलते कौन सा इधर? KCL. Current relation बोलते कौन सा इधर? KCL. Next let us come to Vx. देखिए इधर this Vx is the voltage across the 2 ohm resistance. Vx क्या है? Voltage across the 2 ohm resistance. Now 2 ohm resistance में करंट कितना जा रहा है इधर? I1 करंट. तो 2 ohm resistance में करंट कितना जा रहा है इधर? I1 करंट. We write this Vx equal to 2I1. Vx equal to 2I1. देखो जी 2 ohm resistance में करंट कितना जा रहा है इधर? I1 करंट. Equation 3, equation 2 and equation 1. We got the 3 equations. Okay. Now previously we discussed mesh analysis. in case of mesh analysis, for developing equations, we use a KVL. KVL and the Ohm's law. For developing equations, we use a KVL and the Ohm's law. But the super mesh technique, in the super mesh technique, we use a KVL. We use a KVL and a KCL and the Ohm's law. In the super mesh technique, we use a KVL and KCL and the Ohm's law. Super mesh technique, we use a KVL, KCL and the Ohm's law. अब सिंप्लीफाई करो जी. I gave all the hints. अब इक्वेशन सॉल्व कर सकते हैं आप. हाँ, इक्वेशन सॉल्व करके I1 I2 फाइंड आउट करो जी. आप solve the equations, find out the I1 I2 values. Okay, objective questions के लिए remember this one. Super mesh के लिए we go for KVL, KCL and Ohm's law. Solve करो जी. कौन है नो? सारा सिन्हा. That is a ideal dependent source. It may be independent, ideal independent or ideal dependent source. दोनों के लिए अप्लाई कर सकते हैं जी. ओके, सारा सिन्हा जो रिडक्शन टेक्निक है ना, दैट इज वैलिड फॉर द बोथ इंडिपेंडेंट सोर्स और डिपेंडेंस, दोनों के लिए अप्लाई कर सकते हैं. कौन है? खुशी शर्मा इधर देखिए. और जो नेट करंट है ना Vx/2 है ना, Vx/2 करंट इन द सेम डायरेक्शन ऑफ I2, इसका मीनिंग क्या है बोल तो I2 इज द ग्रेटर व्हेन कंपेयर टू I1. जो रिजल्ट है ना, दोनों के रिजल्ट कितने हैं? Vx/2 इन द सेम डायरेक्शन ऑफ I2. दैट्स व्हाई I2 इज द ग्रेटर. वी शुड राइट द I2 माइनस I1. मान लो इट इज गिवन डाउनवर्ड्स, मान लीजिए डाउनवर्ड्स दिया तो क्या लिख सकते हैं इधर? I1 माइनस I2. चेक करो जी. I1 many students are saying 15/80. चेक करो, is it correct? Fifteen by 8. Check करो. Many students are saying 1.875 I1. 1.875. What about the second one is how much? Many students are saying 3.75. Check करो जी एक बार. Verify these currents. Is that the correct or incorrect? I1 I2 आप चेक करो. Okay. Very good. Many students got same answers. Very good. अब एक वर्कबुक क्वेश्चन देखेंगे. Now वर्कबुक में रीड द सेकंड क्वेश्चन. एक बार सेकंड क्वेश्चन देखो जी इन द वर्कबुक. क्वेश्चन नंबर 2 पढ़ो एक बार. Question number 2, the workbook. चेक करो जी क्वेश्चन नंबर 2 देखो एक बार. सुपर मैश वन स्पेशल केस. खुशी शर्मा जी क्या कर रहे हैं आप? mesh analysis अलग है, super mesh is one special case in that one. Try to understand carefully, don't try to develop new concepts. आप new concept develop किया तो आपको Nobel Prize मिलेगा, be careful. It is the current source branch common for the mesh 1, mesh 2. Current source branch common for mesh 1, mesh 2. We go for the super mesh technique. Now current source branch common for the mesh 2, mesh 3. Again we go for super mesh technique. Then here in this example, can you write a combined equation for the mesh 1, mesh 2, mesh 3? You have write a combined equation for the 3 meshes. क्यों मतलब तीनों के लिए how many super meshes are there in this example? 2 super meshes. देखिए 1, 2 के लिए 1 super mesh, 2, 3 के लिए 1 more super mesh. Then we should write the equation combinedly for the mesh 1, mesh 2, mesh 3 excluding current sources. Excluding current sources. अब equations लिखेंगे. Now corresponds example, if you write the equations, let us start from this one. 2 ohm resistance में करंट कितना जा रहा है? I1 करंट. करंट कितना जा रहा है जी? I1 करंट. देखिए I3 करंट सर्कुलेटिंग इन द 4 and 8. 4 and 8 दोनों कैसा है? सीरीज में है ना, 12 I3. अब देखिए इन दिस 8 ohm रेजिस्टेंस I3 डाउनवर्ड्स, मगर I2 I4 इज अपवर्ड्स. इधर 8 ohms के लिए I3 डाउनवर्ड्स, I4 इज अपवर्ड्स, अपोजिट डायरेक्शन, -8 I4. Now for the 2 ohm resistance, yes 6 ohm resistance, how much current circulating is the I2? What do resistance? 6 I2. We developed equation combinedly. We developed equation combinedly for mesh 1, mesh 2 and the mesh 3. We developed equation combinedly for mesh 1, mesh 2 and mesh 3 excluding current sources. Now we got the first equation. In this example we got the first equation. Now for development of this one, what do we applied here? KVL. What do we applied? The KVL. Now come to current source. Now correspond to this current source, I2 is forward direction, I2 forward direction, I1 in the backward direction. Here the I2 forward direction, I1 backward direction. Then shall I release here I2 minus I1? What is the I2 minus I1 equal to 5? Now which one? This one? KCL. Current relation KCL. Again for this example देखिए I0, I2 is downwards, I3 is upwards. कैसे लिख सकते हैं इधर? I2 minus I3. I2 minus I3 equal to 3. कितना है जी? 3 I0. Now we got the one more KCL equation. We got one more KCL equation. Now come to loop 4. Can I add the one more equation for loop 4? Loop 4 means that mesh 4. Mesh 4 के लिए we are writing equation. देखिए mesh 4 के लिए if write equation I4 circulating 4 and 8. No sorry 2 and 8. 2 and 8 total resistance कितना है इधर? 10 I4. For the 4 ohm resistance, for the 8 ohm resistance, I3 is upwards, I4 is upwards, I3 is downwards. कैसे लिखते हैं इधर? -8 I3. And higher potential to lower potential voltage drop. This entire equation is equated to 0. This entire equation equated to 0. Then total how many equations we got here? 4 equations. For this example, total how many equations we got here? 4 equations. Come to I0. Here the I4 acting downwards, but the I0 is upwards. Can I write this here? I0 equal to -I4. Here the I4 downwards, I0 is upwards. Then you can write this one, I0 equal to -I4. I naught equal to minus I4. I give all the equations. आप सॉल्व कर सकते हैं ना, चेक करो जी. I give all the equations, चेक करो जी एक बार, सॉल्व करो. Vikas Kumar, that equation 5 correspond dependent source. It is not actual mesh equation. Actual equations are only first 4. Okay. And one more point. Now देखिए इधर, is it objective question, conventional question? Objective question. Dear students, whenever you are attempting this lengthy questions in the exam, try to attempt at the end. At the beginning itself, don't take this type of the problems. क्यों बोलते हो, for solving equations sometimes it will take the 5 minutes, 10 minutes, 15 minutes also. That's why at the beginning itself, if you start this problem, unnecessary pressure increase in your brain. Whenever you are attempting this type of lengthy questions in the exam, try to attempt at the end. Remember, it is a lengthy question for all the students, not only for you. You have to think like that. It is a lengthy question for all the students, not only for you. In that way, we have to think. Okay? Anybody answers? बोलो जी. I1, I2, I3 कौन सा ऑप्शन सेटिस्फाई कर रहे हैं? Any answers? Abhinav saying D is the correct option. Others, anybody supporting this one? Abhinav saying D is the correct option. Others, anybody support this one? Neetam also saying D is the correct option. Chakaroji, others, anybody? Bhavana also, same thing I think. Tripathi also D. Oh, Rikit Anand got A option. Oh, क्या हो गया जी? इक्वेशन सेम है, आंसर्स अलग अलग आ रहे. और बोलिए ऑप्शंस. Which one correct, A or D? Others, anybody replying? Only one student got A option, remaining all got the D option only. Okay. Shall I confirm D option? Okay. बाद में चेक कर लो. Don't worry. Very soon I will provide the workbook solutions. That is one. Find loop currents. Find loop currents of the network shown. Find loop currents of the network shown. Find loop currents of the network shown. Okay. Now for this example, देखिए इधर, for this example I1 is acting upwards. देखिए example में I1 upwards, but 15 also upwards. Example में देखिए I1 upwards, 15 also upwards. Can I write this sir? I1 equal 15 amperes. I1 equal कितना है जी? 15 amperes. Now for this particular example, देखो जी, this current source branch common for the mesh 1 and the mesh 3. Example में देखिए, current source branch common for the mesh 1 and the mesh 3. When the current source branch common for the two meshes, we go for the super mesh technique. Super mesh technique के लिए what we do? We write the equation combinedly for mesh 1 and the mesh 3. What we do? We write the equation combinedly for mesh 1 and the mesh 3. मगर इधर कंबाइन इक्वेशन लिखने का जरूरत नहीं है. क्यों बोलते? क्वेश्चन में कौन सा सोर्स दिया है इधर? ऑलरेडी वी नो द करंट वैल्यू. ऑलरेडी वी नो द करंट वैल्यू. I1 इक्वल कितना है इधर? 15 एम्पियर्स. इधर कैसे लिख सकते हैं? दिस ब्रांच के लिए, फॉर दिस ब्रांच I3 इज अपवर्ड्स. I3 इज अपवर्ड्स बट I1 इज डाउनवर्ड्स. ये ब्रांच के लिए कैसे लिखते हैं इधर? I3 अपवर्ड्स, I1 डाउनवर्ड्स. देन हाउ डू राइट रिलेशन? I3 माइनस I1. I3 minus I1 equal to Vx by 9. We got the second equation. एग्जाम्पल के लिए I3 अपवर्ड्स I1 डाउनवर्ड्स, देन I3 minus I1 equal Vx by 9. Now come to loop 2. In this example, let us focus on the loop 2. Now for the loop 2 देखिए I2 current circulates 1 2 3. I2 current circulate 1 2 3. Total resistance कितना इधर है 6. Total resistance कितना है 6 I2. Now for this example देखो जी 3 ohms. The 3 ohm resistance I3 and I2. 3 ohm resistance I2 and I3 both are in the opposite direction. Opposite direction means कैसे लिख सकते हैं इधर -3 I3. Now for this 1 ohm resistance के लिए I2 upwards I1 downwards. I2 upwards I1 downwards. What is the sign for this one? Minus. Opposite direction. This entire equation equated to 0. We developed the KVL equation. Correspond to loop 2. Okay. Come to the one more point. और क्या चाहिए आपको Vx. इधर Vx बोले तो वोल्टेज का 3 ओम रेजिस्टेंस. Vx का मीनिंग क्या है जी? वोल्टेज का 3 ओम रेजिस्टेंस. चेक करो 3 ओम रेजिस्टेंस के लिए I3 is entering at positive terminal. When the current enters at positive terminal, sign for the current is taken as a positive. When the current enters at positive terminal, sign for the current is taken as a positive. Now this is the I3. And when the current enters negative terminal, sign for the current is taken as a negative. When the current enters negative terminal, sign for the current is taken as a negative. I3 minus I2. देखिए 3 ओम रेजिस्टेंस के लिए वन सेकंड रिपीट. 3 ओम रेजिस्टेंस के लिए देखिए I3 is entering at positive terminal, sign for the current is taken as a positive. मगर इधर देखो जी I2 is entering at negative terminal, sign for the current is taken as a negative. Can you solve all the equations now? चेक करो जी. I give all the hints. I1 वैल्यू तो पता चल गया आपको. कितना है जी I1 वैल्यू? हाउ मच? 15. By solving remaining equations आप निकाल सकते हैं ना. Oh, very good. One student got answer R. What is the R? R का नाम क्या है जी? बड़े नहीं है. Okay जी. Okay. Now many students are giving answers now. Who gave the first answer? Vanilla gave the first answer. Then after Bhavana gave the answer. और करेक्ट आंसर्स किसको आ गया? त्रिपाठी को भी आ गया करेक्ट आंसर्स. ओके चेक करो. I2 equal to 11, I3 equal to 17. चेक करो जी. Many students are giving these answers. अंजू चौधरी एक बार आप चेक कर लो जी. एक कैलकुलेशन चेक कर लो. प्रशांत कुमार आप भी चेक कर लो एक बार. सचिन यू आर आस्किंग लूप टू कुछ भी नहीं है. इधर देखिए I2 सर्कुलेट 2 3 1 सब जोड़ दिया तो कितना आता है इधर? 2 3 1 जोड़ दिया तो कितना आता है जी? 6 I2. 3 ओम रेस में देखिए I2 I3 ऑपोजिट डायरेक्शन, साइन क्या है इधर माइनस, इधर 1 ओम में क्या है इधर I2 अपवर्ड्स I1 डाउनवर्ड्स, डायरेक्शन कौन सा है इधर माइनस. ओके ओके next put siding nodal analysis. Next put siding nodal analysis. Next put siding nodal analysis. क्या खुशी जी कुछ काम है क्या आपको? कुछ अपॉइंटमेंट्स है क्या? Next put siding nodal analysis. See, so far we discussed about the mesh analysis. Our mesh analysis valid only correspond planar networks. But if you come to nodal analysis, it is valid for the planar as well as the non-planar networks. It is valid for planar as well as the non-planar networks. And one more thing, in the further chapters, in the steady state AC circuits, theorems, transients, two-port network, for many questions, with help of the nodal analysis, we can easily convert the answers. क्यों बोलते हो? If you observe the previous papers also, in the theorems, transients, steady state, maximum questions they are focusing on the parallel circuits. Parallel circuits के लिए we can easily write the KCL equation by using nodal analysis. That's why in the other chapters also we use the application nodal analysis. That's why in this entire basics nodal analysis is very important. Okay. And our nodal analysis can be applied for both planar as well as non-planar networks. Okay. Write one note. एक point लिखो इधर. एक point लिखो इधर. एक point लिखो इधर. Nodal analysis can be applied. Nodal analysis can be applied for both planar and non-planar networks. Both planar and non-planar networks. Nodal analysis can be applied for both planar and non-planar networks. Planar and non-planar networks. Next, put siding procedure of nodal analysis. Next, put siding procedure of nodal analysis. Procedure of nodal analysis. Procedure of nodal analysis. देखिए, in the nodal analysis, first identify the total number of nodes in the given network. First identify total number of nodes in the given network. Either total number of nodes बोले तो we mainly focus on the principal node. We mainly focus on which one here? Principal node. Now for this particular example, principal node 1, principal node 2. Principal node 1, principal node 2. Identify total number of principal nodes. Then after assign the voltage. Assign the voltage at each node. In this example, let us assume voltage of this one is a V1. Voltage of this one is a V2. After assigning the voltages, select any one of the nodes as a reference node. With respect to convenience, any node is taken as a reference node. with respect to our convenience, any node is taken as a reference node. Generally, in the question itself, they give the reference node. मान लो कुछ भी reference नहीं दिया तो we go for the lower end is taken as a reference node. The lower end is taken as a reference node. Always the reference node potential should be equal to ground potential. Always this reference node potential should be equal to ground potential. Then here in this example, reference node also completed. Next step is write the KCL equation. Develop KCL equation at each non-reference node. Develop the KCL equation. Develop KCL equation at each non-reference node. In this example, with respect to ground, what is the polarity at this point is a plus. Ground potential, lower potential, with respect to this one, V1 is the always higher potential. Now let us write the KCL equation. While writing this KCL equation, always assumption is a node voltage is greater. To write KCL equation, always node voltage greater when compared to all other voltages. With respect to that assumption, we write the equation. Now for this example, there is there plus similar polarities subtraction. V1 minus 20. The resistance कितना है जी 2. इधर assumption क्या है बोल तो always the current has to go from higher potential to lower potential. Assumption is the current goes from higher to lower. Plus. देखिए for this branch check करो इधर plus minus बोल तो addition. V1 plus 6. The resistance value कितना है इधर 3. Now outgoing current, it is also outgoing current. Whatever the 2 amperes is the incoming current. That means sum of outgoing currents equal sum of incoming currents. Here sum of outgoing currents equal sum of incoming currents. Then by simplifying this one, can you find out respect to V1 value? That means by solving the KCL equation, we can find out the node voltage. Point लिखो जी, points लिखो. Write the first point. पहले points लिखो. Write the first point. Identify total number of principal nodes. Identify total number of principal nodes. Second point. Assign the voltage at each node. Comma, one of the nodes, assign the voltage at each node, comma, one of the nodes is taken as a reference node. And reference node potential should be equal to ground potential. Next point. Develop KCL equation at each non-reference node. Develop KCL equation at each non-reference node. Non-reference node. Next point. By developing by solving KCL equations, By solving KCL equations, find node voltages. By solving KCL equations, find node voltages. By solving KCL equations, find node voltages. Node voltages. Simplify करो जी. Simplify करो. By simplifying this one, can you find out V1 value? Check करो. Simplify it, find out V1 value. Simplify करके V1 निकाल सकते हैं ना? Check करो. Many students are saying V1 12. Check करो जी. Is it correct? Okay, very good, very good. Many students are saying. Check करो जी एक बार. Shall I confirm this answer? Okay. Correspond to this nodal analysis. Correspond nodal analysis. Total number of equations equal to n minus 1. For the nodal analysis, total number of equations equal to n minus 1. Correspond to this nodal analysis. Total number of equations equal to n minus 1. Here the meaning of n is what? Total number of nodes. Meaning of n is the total number of nodes. Here how many nodes are there? Check करो जी. How many कितना है जी nodes? 2. 2 minus 1. How many equations? 1 equation. लिख लो जनरल फॉर्मूला लिख लो. Total number of equations equal n minus 1. Total number of equations equal n minus 1. इधर n बोलो तो principal nodes. इधर n का meaning principal nodes. n का meaning principal nodes. Okay, very good, very good. Okay, dear students, with this one today's class completed. Okay.